In this subtopic, we will be looking at objects which move in circular motions. For example, the motion of a car around a bend, motions of the planets around the sun, a spinning DVD in a laptop, the hands of the clock, the wheel of a car or bicycle, and etc. This will enable us to understand why people taking rides in the roller coaster or Ferris wheel, for example, do not fall out from their seat. Before that, we need to understand the definition of circular motion. Circular motion can be simply described as a motion along the circumference of a circle. And how about uniform circular motion? Uniform circular motion is defined as a motion of an object traveling at a constant speed or uniform speed on a circular path. In describing circular motion, we are going to consider an object moving from point A to point B in a circle where the center is 0. The line joining the center, OA or OB, is known as the radius of the circle, which is R. When an object moves from A to B, the radius swaps out at angle theta in time. Here, theta is known as the angular displacement. For an object moving a straight line, its position is defined by its displacement, the distance it has traveled from its starting position. The corresponding quantity of circular motion is angular displacement, the angle of the arc through which the object has moved from its starting position. So if an object moves a distance s, A to B, around a circular path of radius r, its angular displacement in radian is defined as angle in radian equal to length of arc, which is s, divided by radius. Angular displacement is measured in radians. Since it command to quote angle in degree, it is useful to remember that 1 revolution equal to 360 degree equal to 2 pi radian. Look at this simple example. If theta is 60 degree, what is the value of theta in radian? So this is the solution. Theta equal to 60 degree times 2 pi divided by 360. So we get theta equal to 1.05 radian. How to calculate it from here? So 360 equal to 2 pi in radian. So the question is, when 60 degree, what is the theta? So we can do like this. So 360 theta equal to 2 pi times 60 degree. So theta equal to 2 pi times 60 degree divided by 360. So it's the same. So theta will get 1.05 radian. Now we will discuss on speed. Consider this figure. The arrows are straight and show the direction of motion at a particular instant A, B, and C. They are drawn as tangent to the circular paths. As the object travels through point A, B, and C, its speed remains constant, but its direction changes. Since the direction of velocity is changing, it follows that v itself, a vector quantity, is changing as the object moves in circle. In linear motion, the velocity of an object is directed along the line of motion. However, in circular motion, the direction of linear velocity is always directed tangentially to the circular path. Linear velocity is also known as tangential velocity. So now, angular speed. Although its velocity is changing, we can say that its angular speed is constant because it moves through the same angle each second. So we can write as angular speed omega equal to angular displacement, which is theta, divided by time taken. Time taken to make one revolution is referred to as the period t, and the angle through which the object rotates in one revolution is 2 pi radian. Therefore, omega equal to 2 pi divided by t. And relationship frequency and period we can write as frequency equal to 1 over period. So therefore, we will get omega equal to 2 pi f. How to derive it? Omega equal to 2 pi over t. So t, we can replace 2 pi, which is t here. So t, 1 over frequency. 1 over frequency. So you get 2 pi f. In the time interval t, the object moves a distance of 2 pi r. This one, 2 pi r, which equal to the circumference of the object. Circular parts. From definition of speed, so velocity is displacement over time. So for this case, circular parts, we can write velocity equal to 2 pi r, and t is one cycle, which is period t. Therefore, the relationship between speed and angular speed is v equal to r 2 pi over t. So r, we bring in front, so 2 pi over t. So we can write v equal to r omega. Omega is 2 pi over t here. So example 1. Okay, look at example 1. A toy train travels around a circular track of radius 2.5 meter in a time of 40 seconds. What is its speed? So the first one, we can calculate for the angular speed. So angular equal to 2 pi divided by t. So we know that 2 pi, 1 complete revolution, divided by t, t is 40 seconds. So we will get 0.157 radian. And then we can calculate for the speed. So we know the relationship v and omega is v equal to r omega. So v equal to r is 2.5 and omega is 0.157 radian. So we will get 0.39 meter per second. Okay, for example 2, 3313 revolution per minute stand for omega, and the radius 0.15. So the first question determine the angular velocity or angular speed. So omega equal to 331 over 3 revolution per minute. But we know that we need to change to radian per second. So what must you do is 331 over 3, 99 plus 1 is 100 divided by 3 time 2 pi divided by 60. So we will get 3.5 radian per second. Then for B, the speed of a point on its circumference. So we know the relationship V equal to R omega. The R is 0.15 and the omega is 3.5. So 0.52 meter per second. And the last question, the speed of point midway. So let's say this is the circumference from the center. So this is the mid. So we need to determine the V, the new V. So V equal to R omega. So R is 0.15. Because of the midpoint, we need to divide by 2 time and omega 3.5. So the final answer is 0.26 meter per second. Now look at the example 3. Example 3. Given that omega is 5400 revolution per minute, the question asks, determine the period of the motion. Okay. So omega is 5400 revolution per minute. Again, we need to change to rad per second. So 14500 times 2 pi divided by 60 seconds. So we will get 565.5 radian per second. So we know that omega equal to 2 pi over t. So omega is 565.5 equal to 2 pi, and we can calculate for the t. T equal to 0.011 second. Very easy. And for B, the radius of centrifuge is 14 centimeter. How fast? So the question asks for the V. V equal to R omega. So V equal to R is 14 seconds. So convert to meter times 10 negative 2, and omega is 565.5. So you get 79.17 meter minus 1. Centripetal acceleration. Even though an object moves at a constant speed in a circular path, it still has an acceleration due to the changing direction of linear velocity. Centripetal acceleration, the symbol is AC, is defined as the acceleration of an object moving in a circular path with direction towards to the center, and magnitude equal to the square of the speed divided by the radius. So we can write AC equal to V square over R. And unit for AC is meter per second. The AC is also known as radial acceleration, which reminds us of the direction of the acceleration. Newton's first law tells us that an object will continue moving along a straight path unless acted on by external force. And according to Newton's second law, sum of F equal to ma. Therefore, the external force is represented by the centripetal force is sum of Fc centripetal force equal to MAC. Centripetal force is defined as a force acting on the body, causing it to move in circular paths and always directed to the center of the circle. Fc always directed toward the center of the circular path and always perpendicular to the direction of velocity. FC and AC are always directed to center of circular parts and always perpendicular to direction of linear velocity. For uniform circular motion, the magnitude of the centripetal acceleration always constant, but its direction continuously changes as the object moves around the circle. We can look from this figure. This is the A, this point, and this is the V velocity and direction FC, and AC always toward to the center. What direction will it go? Look at this situation. The direction of rotation and then snap. So what happened? If the centripetal force suddenly stopped to aid on the body in the circular motion, the body flies off in the straight line with the constant tangential linear speed as shown in this figure. So we look at example 4. A motorbike moving a constant speed 20 meters per second in a circular track of radius. This one V and this one is R. Calculate the centripetal acceleration of the motorbike. As we know that AC equal to V squared over R. And V is 20 power of 2 and R is 25. So we'll get 16 meter minus 2. And for B, the time taken. So we know that V equal to R omega. 1 complete revolution. V equal to R omega. And we know that V equal to 2 pi R over T, because omega is 2 pi divided by T. So V is 20, 2 pi, R is 25, and T we don't know. The T we need to determine because of the question asked to determine T to 1 complete revolution. So when we calculate for T will get 7.85 seconds.